Welcome back, everybody. Did you have a good morning tea? Cool. Okay, well, we're going to dive straight into the next talk. We have BernardO'Leary from Spark. Where are you based? Are you based here in Christchurch?
Auckland.
Who has come down from Auckland today to talk to us about dependency injection. I'm really looking forward to hearing about this. It's a topic that I feel I don't know enough about. So without further ado, thank you, Bernard.
Thank you. Okay, so yeah, dependency injection with Python. Just wanted to kick off with a bit of an overview of how the talk is going to go. So going to take you on a little bit of a journey. I'm trying to squeeze a lot in, so I'll probably move from slide to slide reasonably quickly. I would describe this as maybe a 200 level talk, so you know, not a great deal of technical prerequisites, but maybe if you know about object-oriented programming, that'd be pretty useful. Yeah, we're going to sort of have a look at brief history of design patterns as well to sort of lead us into that, and just round it out with a bit of a summary and have a look at some of the tools that are available for dependency injection with Python. So this is a Sinclair ZX Spectrum 48. This is what I learned to program on back in the 1980s. My experience with this computer was my brother and sister sitting watching my dad increasingly furiously smash sort of BASIC into this, which is essentially a BASIC compiler implemented in hardware in front of a CRT monitor, or CRT television in fact, that's plugged into it. And he would do that until he basically would rage quit and go to bed. So, you know, that was my first experience with programming. But yeah, obviously stuck with it. It's good fun. Originally was a MS Access developer. This is going back sort of 20 odd years ago. Transitioned into .NET and did a lot of C# development, then web apps, then cloud, dabbled in C++. And Java and Python has sort of been a constant thing that I've done over the last, my whole career. Last 10 years I've been working in architecture, so I didn't really classify myself as a programmer when Laura asked the question yesterday, but I'm reclassifying myself now based on her talk as a programmer. And most recently I've been working with an awesome team of automation engineers with Spark, where we do lots of Python. So I try to code every day. I'm not a great coder by any means, but I do recognize that there are things that help me code better, and one of them is dependency injection. I've found it really useful. First encountered it maybe 15 years ago when I read Kent Beck's book, Test-Driven Development. I wouldn't recommend trying test-driven development, or I recommend trying test-driven development, but I wouldn't recommend trying to enforce it as something that you do in your development team. It's pretty hard, but what I did get out of that book and attempting and practicing test-driven development for a little while was that dependency injection is pretty cool. So that's why I wanted to talk about it. So just sort of to back it up a little bit and sort of come at the idea of dependency injection from a design perspective, wanted to have a look at why it's important to consider design. So here's an example of a dashboard that perhaps may or may not be a nuclear power plant's dashboard. I don't know, but it looks like it might have been, and maybe design would have been a good thing to consider before putting this together. Another one here, a bit of design collaboration between the people who built that fire escape and the people who built that cage underneath the fire escape would have probably been quite useful. This is, I actually kind of like this, but, clearly there was one set of designers that wanted to make something like a gaming console and another one that had a requirement to make a phone, and we got this. The concept clearly didn't take off. Maybe a nice experiment, but an interesting sort of study in design. And there's not really any words for this, but I'm sure sort of ACC would have an opinion on it. What is a design pattern? This is ripped straight from Wikipedia, and I'm going to paraphrase it and say that really, I think a design pattern is kind of like standing on the shoulder of giants. It's where engineers over time have solved the same problem sort of over and over and over, and someone at some stage has decided, well, I've solved this problem 2 or 3 times now. I'm actually going to write down the process that I've gone through to solve the problem, and they've published it, and that's where we get design patterns from. So why are design patterns useful? I thought this is a pretty good sort of illustration of, in the sort of physical world, why design patterns are useful. This is obviously a pedestrian crossing. This is the Abbey Road one, famous for the Beatles album cover. The first pedestrian crossing was put down in 1951, just around the corner from this one, but it's clearly a globally recognisable design pattern. Anywhere in the world you encounter one of these as a driver or a pedestrian, you're almost certainly going to understand the behaviours that are associated with it. Design patterns can go wrong though, or design can go wrong. Can be good designs can be overused or misused, or we can get sort of patterns build up as a result of sort of no design being put in place, or no design sort of guidance being provided. This is a real place. It's not a sort of fractal image. I can't remember where it is, but perhaps an example of where design could have been done better, where an anti-pattern has crept in. So where did the idea of a design pattern originally come from? This is a book that was published in 1977 by a building architect called Christopher Alexander. So he obviously had a few collaborators. This book is not the most exciting read, but it talks about the idea that over sort of millennia, where cities and towns and houses and that have been built, there are these sort of common patterns to what makes a successful city, town, house sort of thing. And the book basically says this is how we can sort of define these patterns and go about sharing them with other people. Christopher Alexander wrote a sort of a partner book to this called I can't remember what it's called. A Timeless Way of Building. That's what it's called. That's a much more interesting read. So if you're going to read one of his books, I recommend that one. The design patterns book sort of set the stage for this book, which is kind of the staple if you do a computer science course in design patterns. This is 1994, Christopher Alexander, the building design patterns guy, actually from the mid-90s onwards has been closely collaborated with the sort of world of software. So that's an interesting sort of merge of ideas that's taken place there. This is a page out of the design patterns book, just to show how these patterns all sort of link to each other. This is 1994. Obviously, there's a lot more design patterns nowadays for software, including our topic of the day, or topic of the next 20 minutes or so, inversion of control, also known as dependency injection. So this is perhaps the simplest way to articulate the dependency injection pattern. On the left-hand side, we've got a couple of objects, one referencing the other, where there's no sort of decoupling, and on the right-hand side, we've got decoupled reference from object B to object A via an interface. So this is sort of clearly a object-orient or not a dynamic typed representation here, but yeah, it's kind of an okay way to look at it. So what is the dependency injection pattern? Essentially the idea is take your dependencies in your code base, and by dependencies what I mean is anything that's external to your code base where you've got a dependency on it but you don't have absolute control over it, such as a database, a network, a file system, you know, maybe an IoT sensor or something like that. Wrap them in a class definition so that they're only reachable through instances of an object. Define get a set of methods so that you can do stuff with your dependency through the class definition, you know, include your key operations in there, and inject those dependencies down through your code base, aiming for reuse. So the idea is that you instantiate the classes that you've wrapped your dependencies in, ideally sort of once at the top of the call stack, and inject them down through classes as you need them through the code base. So here's just to sort of set the stage, a couple of, or an example of a bit of code that has no dependency injection, obviously no object-oriented code in it either. Left-hand side, we've got a dependency cloud storage that does a file upload to AWS using the Botto library. And on the right-hand side, we've got our API app module that has a couple of endpoints defined on it using Flask. One to upload a happy face and one to upload a sad face. And we can see that we call the upload file function twice there, which results in the Botto client being instantiated twice. You know, all of that sort of standing up of that dependency needs to happen twice, and you know, you don't have very good sort of code reuse there. So, you know, if you were to sort of grow this code base big, then it wouldn't be a particularly sustainable way to do it. So, sort of next step, if you're trying to sort of move toward dependency injection or even just sort of a bit of code reuse, is to wrap your dependencies in classes. So on the left-hand side, we've got our cloud storage class, which could have been used in the previous code base to wrap our Botto client. On the right-hand side, you know, an example of a database access class. Moving sort of more toward dependency injection, we take our class definitions that wrap our dependencies. So we've got our triangle and our oval there, sort of representing our database and our Botto integrations from the previous slide, and we instantiate them at the top of the call stack in our teardrop class here, class definition. And then further down the call stack with our star and lightning bolt class definitions, we'll take our instantiated oval and triangle instances and inject them into the star and the lightning bolt, ideally through constructor parameters or otherwise, you know, sort of early on in the standing up of, or the instantiating of that class as instance variables. And then to sort of, you know, look at the sort of next level, you can see that our lightning bolt class can then be injected further down the stack into donut class here, which is sort of, you know, we've got the lightning bolt class, which has the triangle class in it, which wraps its dependency, but you know, we can apply the same sort of dependency injection mindset to reuse our instance of the lightning bolt class there. So at this stage, we've got sort of basic dependency injection going, and we've kind of achieved the idea of the dependency injection pattern. To sort of bring it full circle, you can introduce an inversion of control container, also known as a dependency injection framework, and that sort of makes things look like this. So in your teardrop class now, you've got this sort of cube here, which represents our inversion of control container, and the instances of our triangle, our oval, and even our lightning bolt class, which holds our triangle wrapper in it, are held by that inversion of control container. And the only thing that the teardrop class does is instantiate the inversion of control container. The inversion of control container then basically manages the sort of distribution of the instances of the classes that we have that have dependencies in them, or that use dependencies in some way. And the inversion of control container is then sort of responsible for pushing those instances down the stack. And we call it inversion of control because literally, instead of in the donut class, perhaps, like a more naive approach to writing this program, if you're using the oval and triangle wrapper classes, would be to new up an instance of the oval class within the donut class there, or to new up an instance of the lightning bolt. But yeah, that sort of means that you've got dependencies being fired up all over the place. You're not getting particularly good code reuse. The idea here is that you're just managing the injection of dependencies down the code base from a single place. So this example is ripped directly from the sort of front page of the dependency injector inversion of control container, which is one of the more popular ones, and we'll have a look at a bit of a list of inversion of control containers shortly. So on the left-hand side, we've got the definition of a container class, which inherits from a declarative container, which is defined in the dependency injector package. And then we stand up a couple of providers, a singleton provider and a factory provider. We define an API client, which is our external dependency, as a singleton, so we're only going to have one instance of it across the whole code base. And then we've got a factory provider, which gives us a service class instance. So the idea is you call a factory provider, you get a new instance of the service class, but your API client is the same across the code base. It's a singleton. On the right-hand side there, our main method has the service class as a parameter, and that's provided by the dependency injector provider. And when we call that, we don't actually need to specify what we're passing into that method. The inversion of control container automatically injects that dependency. You can see that down the bottom there. When you call main, you don't need to specify any parameters. The inversion of control container manages that. That's handled by decorating the main method with the inject decorator, by the way, up the top there. And you can actually send in a mock instance of, for example, the API client. So if you wanted to call main again with a mock instance of the API client, you're going to get a new instance of the service factory that has your mock API client in it, and you just call the same main method, and everything's handled there. So the other thing to have a look at is the container.wire method. That basically sort of stitches the whole lot together. There's obviously a bit of stuff going on in the background there. So yeah, I think that's probably all for that slide. I think in my experience using dependency injection, it's kind of best to keep it a little bit loose. Like I say, like an inversion of control container is a kind of a reasonably strict sort of construct to overlay across a code base, and it does sort of dampen, I guess, the sort of potentially the creative energy of your engineers, or of a engineer. Like personally, if I've sort of say to myself, whenever I'm standing up a code base, I need to have an inversion of control container, it sort of kills the buzz a bit, like especially if I'm wanting to do a quick proof of concept or something like that, it's just not appropriate to muck around and try to stand up an inversion of control container for that. So, it should be used with discretion, but I guess what I'd say is if you're trying to sort of get a team of engineers to pull in the same direction, or you're working with a big code base that perhaps there's been not a great deal of sort of design guidance happen with historically, setting up a dependency injection as like a practice that you want to sort of pull toward gets everyone sort of pulling in the same direction, and incrementally over time you start to get some good sort of uniformity across the code base. Dependency injection can also free up creative thinking in the right way, like I think a lot of the time, as programmers we want to sort of explore different things and go all over the place and try new ideas, which is awesome and is a good thing and is to be encouraged. But if you have a goal to achieve, you want to sort of direct that creative energy. And yeah, having sort of dependency injection as something that you're using or you're encouraging means that people are not going to go off and or necessarily go off and try to sort of transform the code base in a way that wouldn't necessarily be conducive toward achieving your goal. So that being said, there are some pretty cool IOC containers out there. If you're using, if you're doing a large web application where you've got a bunch of Python code, even a medium web application, these are worth looking at, or medium-sized application of just about any type. This again is sort of ripped straight from the GitHub page of a guy called Stefan Firmager. Really awesome web page. I think these slide decks are going to be available after the conference, so there's a link in here if you want to have a look at that. I wanted to touch just really briefly on monkey patching, because I think dependency injection can sometimes be seen as a sort of counter to monkey patching. Monkey patching is something that I've only really just recently encountered. Basically, it gives you the ability to replace an instance of a function with another instance of a function at sort of runtime. So it's a really cool feature that I could see myself abusing extensively, given the opportunity. But it's and it can actually be quite useful for testing purposes, but it doesn't give you that sort of that reusable, I guess, consistency across your code base, or it doesn't sort of lend itself to decoupling either across your code base. So yeah, it's just something to be aware of. I can see that there could be a sort of an argument one way or the other. If you're just looking at dependency injection specifically for testing purposes, but yeah, they're sort of two different things. This is just a really quick example of how monkey patching works. You can see a class definition, class A there. We've got func over on the left-hand side. Over on the right-hand side, we've got our monkey F method definition, and then we say monk.a.func equals monkey F, so we're basically saying that we want that func method to be replaced with the monkey F definition. We create an instance of the A object, and then we call object.func, and we get monkey F has been called printed out. So if you're looking to do something just specifically for the purpose of unit testing, this is pretty useful, but like I say, it's different from dependency injection. So just something to be aware of. So why adopt dependency injection? There's a swear word on this slide. I'm sorry about that. But hopefully I won't be banned from the Python conference in future. But this is a kind of a famous diagram. Certainly I've seen it used around the place a lot, the creative process. And this is definitely my experience when I don't have a great deal of guidance given a sort of a project spec. Like I'll spend most of the time that I have available to me just trying different stuff and mucking around and seeing if this works, seeing if that works, and then I'll panic at the end, and I will spend a bit of time crying late at night while trying to achieve a deadline. I guess introducing dependency injection with a team, or just as a practice that you do for yourself, gives you the ability to sort of direct your creative energy rather than spending that time mucking around. And it's important to spend time mucking around and trying stuff. And like I say, that's part of the cool thing about being a programmer, is you can do really cool, interesting stuff. Adopting a design pattern like dependency injection gives you the ability to sort of direct your creative energy a bit better. So just to summarize, dependency injection is kind of a light touch means of getting a development team pulling in the same direction, or just for yourself. Over time, if it's applied incrementally, especially across a legacy code base, it can give you a sort of a decoupled, composable code base, which is the general idea. Monkey patching is kind of at odds a little bit with dependency injection, so if you've got an existing culture of monkey patching, you might have to justify DI a little bit more. There's some really good dependency injection frameworks out there that are worth having a look at. But use them at your discretion. You don't want to unnecessarily add overhead. So, ngā mihi, thank you for listening.